Now let's proceed to the demo execution, and let me switch to VS Code for easy navigation. Our main logic is located under off-chain directory in test, examples, addition, contract seath, under the main test. And we prepared two runners for it, one for local private network provided by Bluetooth tool, and one for pre-production real testnet. Both setups have integration in Cardano transaction library and can be easily set up and run with Nix. And we're gonna run this demo using Nix also. The milestone 2 proof of concept focuses on proper transaction chaining. So for this demo, we assume that a leader is already elected and that the leader and all users are available during the whole execution process. Also, network communication is out of the scope for milestone 2, and we simulate communication between the leader and the users and action passing right inside the contract we are going to run. And to run the contract, we use key pairs generated by Cardano CLI. Cardano transaction library has an integration for them, so the keys can be used as a wallet to run the contracts. And all wallets were funded beforehand from Faucet. So in current setup, we will have 4 users that want to perform an action which will change protocol state, and the action is just add 100 to the current state. And this is the type that describes such action. This is something that will be configurable by application developers according to their needs. They can just make arbitrary type to describe the action that they want to perform, and then describe the way how to translate this action into transaction lookups and constraints. So besides wallet setup and some pre-flight checks, main contract has 3 major parts. Those are building the actions or generating actions by users. Then those generated actions passed to the leader, and leader built balanced transactions from these actions. And when actions are ready, I mean transaction chain already, the chain of transaction is submitted to chain, to blockchain, and the whole chain is submitted at once. There is no waiting and confirmation of previous transactions, so there is no contention between users, and all 4 transactions will be submitted at once, but the effect that they will produce on protocol state will be the same as each user in sequence apply his own action. So it will lead to desired state change without any contention and without fallen transaction from other users. So let's start an execution. I have pre-production setup running already. This is also a capability of Cardano transaction library. You can launch everything you need using Nix run command. And I want to check that node is synced, and it is. And now I'm going to start execution on pre-production network. And this is the first time I'm running execution for contract, for freshly generated contract. So some setup will be performed before chain will be built and submitted, but we're gonna see it in logs. So here execution is started. This is our setup. Let me fix it. This is our setup. One leader and 4 users that will produce actions. There is some pre-flight checks, and now because contract was freshly generated with the new address, we need to wait while initial state will be transaction with initial state will be submitted by separate wallet of administrator. And now it's done, and we can see the initial state of the protocol. So here we see the leader and all wallets that participating in Seath execution were initially funded with 500 ADA, but I already used this wallet several times to run simulation, but layout was the same every time, and so you can see that the leader still have 500 ADA because leader does not pay anything for submitting transactions. Users will provide together with an action all inputs that are required to balance transaction, pay minimum ADA, and pay fees for transaction. So leader not losing anything, and ideally in future, leaders should be able to collect fees from users for building transaction chain and submitting this chain to blockchain. And here we see initial state of our protocol, and it was initialized to be 100. And here is the datum, which contains this initial state. So this and these numbers should be always the same. When script was initialized, protocol state was initialized, users prepare their actions. So this is the actions generated by users, and each action says that user want to add 100 to the current protocol state. So we should have 500 at the end. And an add amount, it is those type I showed earlier that application developers will be able to create themselves according to their needs. So after actions are ready, they are passed to leader, and leader builds transactions chain, and we can see that it build it for transactions. And from the timestamps here, we can see that all 4 transactions were submitted almost simultaneously. And this is the final chain of transaction IDs that were submitted to blockchain by the leader. Just to prove that there was no waiting between transaction submission, we query whole protocol state again. And we can see that there are no changes at all, and the state is still 100. After that, we are waiting until last transaction in chain will be submitted. And after that, we query state again. And this is the final state of the protocol after set execution. And we see that there is no changes in leader again. There are some changes for the users assets because users had to pay fee and minimum ADA amount. And finally, we see that final state of the protocol was changed according to all four actions that users generated during this execution. Now we can check transaction IDs on Cardano scan, for example, to make sure everything worked as we expected. So let's search first one. Here it is, and we can see that this transaction was submitted in slot 32,833. So let's check next transaction in chain. And we also see that it was submitted under the same slot. And we can check other two transactions also. Same slot here. And same slot here. So this is really good because from the user's perspective, they just submitted all the actions at the same time. And under the hood, those actions were chained as a chain of transaction, and all four transactions were submitted in single slot without any contention between users or failed transaction or stuff like that. And this is exactly what we want to provide to application developers. We can run execution like one more time or arbitrary number of times until wallets have some funds. And there is no initiation now because state was already initiated, and we see same picture, transactions submitted almost simultaneously, and after waiting of the last transaction submitted in chain, we see that state was again properly updated, no transaction failed, and no user action were discarded. And just to be sure, let's search this ID on network. So seems like it's not indexed yet. Let's wait a bit. Here it finally. So we see it was submitted in slot 32,202. And let's check last transaction in chain. And we see the same slot. So run was successful and all four transactions were submitted under the same slot. Probably it won't be the case all the time, but in ideal situation, the whole chain of transaction will land just in the single slot. So this is it for the demo, and thank you for watching.